Let's read the question. Okay, an aerostat of mass m. Aerostat is nothing but helium balloon. Okay, or assume helium balloon. Helium balloon of mass m starts coming down with constant acceleration of w. So instead of w, I'll use the variable a. Okay, determine the ballast mass that has to be dumped from the helium balloon to reach an upward acceleration of the same magnitude. The air drag is to be neglected. So what is happening out here is there is a helium balloon, okay, which has mass m. Now that is moving down with constant acceleration of a. Okay. Now why does helium balloon rise in the atmosphere? It rises due to a thing called buoyancy force. Buoyancy force. Buoyancy force is the same thing that causes things to float on water. Okay. And buoyancy force is given by density of the surrounding fluid. That means density of the air around the balloon into volume of the balloon. Density of the surrounding fluid, okay, into volume of the balloon. That is a buoyancy force. Okay. So there is a downward force of mg acting on it. So out here, if I draw the equation, if I assume upward to be positive and downward to be negative. Okay. So force of buoyancy minus mg is equals to minus ma. Why minus ma? Because the acceleration is in negative direction. Now what happens is I'm dumping some amount of mass out here, delta m. Okay. Now see what will happen. What will happen to the balloon? This was the same balloon. Okay. If I dump some mass from out here, will the volume of this balloon change? No. So if the volume of this balloon does not changes, the density of the surrounding air does not changes, will the force of buoyancy change? No. So the force of buoyancy will remain same as it is. Okay. But out here, what happens? Now the mass of the weight the balloon was carrying, okay, or the ballast weight, okay, is now changed from m to m minus delta m. M minus delta m. Why? Because I threw out delta m from this mass. Okay. So out here, the force on gravitational force will decrease. So now gravitational force would be m minus delta m into g. Now due to the decrease in mass out here, what happens? The gravitational force decreased while the buoyancy force remains same as it is. So what will happen is the acceleration will change. And the question is saying the acceleration changed in such a way that the balloon started moving upward with the same acceleration, same magnitude of acceleration. Okay, find the value of delta m. So out here, what is the equation out here? Fb minus m minus delta m g is equals to m minus delta m into a. Why positive? Because upward is positive, downward is negative. So Fb is positive, m minus delta m g is negative. So this is our equation 1. This is our equation 2. Now solving these two equations, we have to find out the value of this delta m. Okay, find determine the value of ballast mass that has to be dumped. That means this is nothing but delta m out here. Okay, so out here, if I write the equation Fb minus m minus delta m into g is equals to m minus delta m into a. This is our equation number 2. So out here, how do I solve it? I simply apply minus out here. So this will be changed to plus. This will be changed to plus. So FB and FB would get cancelled. So it would be mg minus mb minus how much? M minus delta m into g is equals to how much? Ma plus m minus delta m a. Now from this equation, what do I need to isolate? I need to isolate the value of delta m. Okay, so let's change, or let's send the all the values of term that contains delta m to the right hand side and bring all of the other terms to the left hand side. So I'm writing this or solving this equation out here. Okay, or mg, okay, minus ma, mg minus ma is equals to, acha, let's expand this equation before solving it. Okay, or mg minus mg plus delta mg is equals to ma plus ma minus delta m a. Now all the term that contains delta m will be sent to the right hand side, and all the content term without delta m will be sent on the left hand side. Simple equation solving. Okay, so mg minus mg is equals to 0. Okay, ma plus ma is equals to 2ma. Okay, so out here delta mg is equals to 2ma minus delta ma, or delta mg plus delta ma is equals to 2ma. If I take delta m common, delta m g plus a is equals to 2ma, or the mass that has to be dumped is equals to 2ma by g plus a. This is the mass that has to be dumped from the this load, so that the balloon starts rising up with the same acceleration. Okay, in this question what has been said that is that this mass is driving these two block along this direction. Okay, find the acceleration of this block, or find the acceleration of all the blocks, and find the tension in this tree. So whenever there is a problem in mechanics, okay, so the first thing is assign the direction of acceleration. So suppose I'm assuming this body moves down with acceleration a. By common sense, okay, this body will also move in this direction with acceleration a, and this body will also move in this direction with acceleration a. Okay, now draw the free body diagram of all the bodies m naught. Okay, this is moving down with acceleration a. The forces are m naught g, and the forces are t1. Okay, let the tension forces be t1 out here, t1 out here. If the string is same, the tension value of tension is same, and tension force always acts away from the body, so t2. Okay, so there are two strings and two types of tension forces. So t1, this is the free body diagram of m naught. Let's draw the free body diagram of m1. m1, okay, it is moving in this this direction. Okay, so the coefficient of friction is equals to k. So out here the value of frictional force would be equals to k mg. See, the value of frictional force is equals to kmg in this case, but always remember friction force is equals to coefficient of friction into normal reaction force, and when the surface is flat, n is equals to mg. Okay, so take care of the value of k into n, where n is equals to mg out here. Okay, I have done it directly, but you will take care of this one. Okay, and out here there's a value of tension to T2 force, there's a value of tension T1 for mass m3. Okay, this is moving in T2. Okay, the friction force is k into m3g, this is k into m1g, and is moving in the same direction as acceleration a. Okay, now you have to solve this equation. To write down the equation, we first have to assign the coordinate equation. This is positive, this direction is negative, upward is positive, downward is negative. So for the first body, T1 minus m naught g is equals to how much? Minus m naught a, because the acceleration is in negative direction. Okay, for body B, or for this body, what is the equation? T1, okay, let's write the equation on top of each other. It will be much nicer. t1 or minus t1 plus t2 plus k m1 g is equals to minus m1a. Why? Because this direction is negative, all the forces in this direction is positive, and the acceleration is in negative direction. For the third body, minus t2, okay, then what happens? Minus t2 plus k m3 g is equals to minus m3 a. Okay, these are the three equations from the three bodies. If you add all of this equation together, what do I get? Plus t1 minus t1 gets cancelled, plus t2 minus t2 gets cancelled. So minus m naught g plus k m1 g plus k m3 g is equals to minus m naught a minus m1 a minus m2 a. Okay, this is not 3 but 2, minus m2 a, and this is also 2 out here. This is also 2 out here. This is mass 2. Okay, 0 0 1 2. Okay, so let me rectify all the mistakes out here. So out here, what do I need to find out? I need to find out the acceleration. Okay, so take all the acceleration common, or minus m naught plus k m1 plus k m2 into g is equals to minus m naught minus m1 minus m2 into a. Okay, if I solve this one out here, what do I get? A is equals to minus m naught plus k m1 plus k m2 into g divided by how much? Minus m naught minus m1 minus m2 is equals to a. Now can I do something? Can I take minus common out here from the denominator? If I take minus common from the denominator, what it will be? It will be something like m naught plus m1 plus m2, and if I take minus common from the numerator, it will be something like m naught or plus m naught, okay, minus km1 minus km2 minus km1 minus km2. Okay, understood? So the value of acceleration would be this one. Okay, now we have obtained the value of acceleration, or the value of acceleration in terms of k and masses. Okay, now out here we need to find the value of t2. Okay, so the value of t2 can be obtained by using this equation. So if I use this equation out here, minus t2 plus k m2g or k into m2g is equals to minus m2a. Okay, or what do I need to find? I need to find the value of t2, or t2 is equals to m2a plus k m2g. Okay, or the value of t2 is equals to, I'm taking m2 common, a plus kg, a plus k into g, but the value of a is given by this equation. Okay, so out here t2 is equals to m2 into a. What is the value of a? M naught minus km1 minus km2 divided by m naught plus m1 plus m2, m naught plus m1 plus m2 into g, okay, plus k into g. Understood this one? Now can I take g common from both and take it outside? Of course I can. So let's take g common. This is nothing but equation solving. Okay, so T2 is equals to, I'm doing it fast. Okay, I'm multiplying the numerator km1 minus km2 plus, I'm multiplying k with entire this term. Okay, km0 plus km1 plus km2 divided by the entire denominator. The entire denominator is m0 plus m1 plus m2. Acha. Plus km1 minus km1 will get cancelled. Minus km2 plus km2 get cancelled. Or T2 is equals to m2g into m0 plus km0, or m0 plus km0 divided by m0 plus m1 plus m2. Okay, I'm taking m0 common. So if I take m0 common, what will happen? 1 plus k, or 1 plus k into m0 out here. So this is the value of tension 2. The value of tension 2 is equals to how much? T2 is equals to m0 m2g into 1 plus k divided by m0 plus m1 plus m2. This is the answer, or final answer. Okay. But in this question, we'll try to solve part 2 of the question before solving part 1 of the question. What this question is saying is that there are two blocks, block 1 and block 2, okay, of mass m1 and m2. Block 1 has coefficient of friction k1 with the inclined plane. Block 2 has coefficient of friction k2 with the inclined plane. Okay, and after a certain while, or at certain angle alpha, after certain angle alpha, it starts slipping. Okay, so they're moving with common acceleration a. Why common acceleration? Because out here it is given k1 is greater than k2. Okay, if k2 was greater than k1, okay, or if there was no common acceleration, then what would happen? These two blocks would travel separately. Okay, part 2 of the question is saying find the minimum value of alpha at which the bar starts sliding down. So what is the minimum value of alpha at which the bar starts sliding down? See, whenever there is a inclined plane, okay, there is a block kept on inclined plane. Now as I raise the value of alpha, what is preventing this block from sliding down is the friction force. Okay, the maximum, say the maximum value of friction force is 5 Newton. This block has a maximum capacity of friction force of 5 Newton. The driving force of gravity force up till now is 3 newtons or 2 newtons or whatever. Okay, after a certain while, what will happen? The component of, or mg sine theta, the value of alpha would be such greater that mg sine theta has already surpassed the maximum or limiting factor of friction force. Then what will happen? The body will slide off. So how do we solve this type of question is, just before sliding, when the component of gravitational force is equals to the component of friction force, what is the value just before sliding? What is the value of acceleration just before sliding? So when you need to find out the value of alpha at which the body starts sliding, out there we take acceleration is equals to 0. Just before sliding, acceleration is taken as 0 or 0.00001, which can be approximated as 0. Okay, so acceleration is equals to, just before sliding, 0.0000 infinitely 1, because even if there is a small value that is sliding, no, which is approximately equals to 0. Understood the approach? Okay, I'm solving part B of the question first. So let's draw the free body diagram. Acceleration is equals to 0 to find out the value of alpha for which the body starts sliding. So out here, whenever we have inclined plane, always take the component along the incline and perpendicular to the incline. So out here, m1g sine alpha, k1 m1g cos alpha. Okay, out there is a normal reaction force exerted by block 2 and block 1. Okay, and the value of acceleration is equals to a. Let's draw the free body diagram of block 2. Out here M2G sin alpha, out here K2M2G cos alpha, and in this direction the value of normal reaction force would be in this direction. This normal reaction force is nothing but the normal reaction force exerted by block 2 on block 1. That means there is an equal and opposite reaction force, this normal reaction force, is nothing but this one, okay, and this normal reaction force is nothing but this one, the reaction and reaction pair, okay, acting on different bodies and on opposite direction. Newton's third law, they have three conditions. Every body has equal and opposite reaction. The action and reaction pair will act on different bodies, okay, and third one is they'll be in different direction. So let's write down the equation. I'm assuming this direction to be positive, this direction to be negative. A general rule of thumb for solving equations in this chapter is try to assume the direction of acceleration as positive. Okay, is it a necessary condition? No, but it will help you in most of the cases. Okay, so okay, if I do m1g sin alpha minus n, sorry, plus n minus k1 m1g cos alpha, let me erase this one, is equals to m1a. This is equation number 1. This equation we obtain from this body. Now let us draw the equation of this body. Okay, m2g sin alpha minus n minus k2 m2g cos alpha is equals to m2a. Okay, number 2. When you add these two values, what do we get? Plus n minus n. m1 plus m2 g sin alpha minus k1 m1 plus k2 m2, I'm taking g cos alpha common, into g cos alpha is equals to m1 plus m2 into k. Okay, if we divide the entire term, we get the value of, or if we divide this entire term by m1 plus m2, we get g sin alpha minus this term divided by m1 plus m2, g cos alpha. So a is equals to g sin alpha minus k m1 or k1 m1. Let me draw it properly. K1 m1 plus k2 m2 divided by m1 plus m2, k, into g cos alpha is equals to the acceleration, okay. So this is the value of acceleration that we have. Okay, to find out the value of theta, to find out the value of alpha, alpha means the value at angle at which the block starts sliding, the value of a should be put equals to 0. So the value of a is equals to 0. Okay, so if we solve this acceleration putting the value of a is equals to 0, we'll get the value of sin alpha. So if we put g sin alpha is equals to, see, I have put this a is equals to 0 and taken this entire term to the right hand side, is equals to k1 m1 plus k2 m2 by m1 plus m2 into g cos alpha. G and g would get cancelled. Okay, if I send this cos alpha to the left hand side by cos alpha, okay, sin alpha by cos alpha is nothing but tan alpha. So this is nothing but tan alpha. So tan alpha should be equals to k1 m1 plus k2 m2 divided by m1 plus m2. So tan alpha should be greater than k1 m1 plus k2 m2 by m1 plus m2. Now we'll solve the first part of the question, which basically says find the value of normal reaction force. So what I'll do out here is I'll substitute the value of acceleration that I obtained out here. Okay, in this equation. Okay, not in this equation, out here in this equation, the n is annulled. So out either out here or out here. Okay, substitute the value of a either out here or either out here. You can take any one of the equation. So suppose I'm taking equation 1. Okay, and before substituting, let's make it little bit neat and clean. I'm taking g common out here. G sin alpha, I'm writing sin alpha as s alpha minus k1 m1 plus k2 m2 by m1 plus m2. Okay, into cos alpha is equals to a, and I have taken g common out here. Okay, so I'm taking first equation and substituting the value of a out here. So m1 g sin alpha plus n minus k1 m1 g cos alpha is equals to m1a. So the value of n would be nothing but, if I send this entire term, okay, to the right hand side except n, what will be? N is equals to, or n is equals to m1a minus m1g sin alpha plus k1 m1g cos alpha. Okay, now what I'll try to do is I'll try to substitute the value of a. N is equals to, acha, can I take m1 common from out here from this three equation? So if I take m1 common, what will happen? M1 into a minus g cos alpha. So from out here, m1 would get erased, out here m1 would get erased. So our equation would be m1 into a minus g sin alpha, a minus g sin alpha plus k1g cos alpha. So plus k1g cos alpha. I've just taken the m1 common from all the equations. Okay, so n is equals to m1 into, what is the value of a? Value of a is nothing but g sin alpha minus k1 m1 plus k2 m2 divided by m1 plus m2 into cos alpha. Okay, Asha. This is the entire term. Okay, minus g sin alpha plus k1g cos alpha. So I can take g also common out here. If I take g common, g will erase from here, and from here. So it is nothing but k1 cos alpha. K1 cos alpha. Okay. Out here, if you open the bracket, sin alpha and sin alpha would get cancelled. Sin alpha minus sin alpha is equals to 0. So out here it would get erased. Okay. Now the remaining terms are these two equations. Okay. This equation and this equation. This term and this term, not equation, term and term. Can I take cos alpha common from both this term? Of course. So if I take cos alpha common, be cos alpha into cos alpha would get eliminated from both the term. So out here cos alpha plus k1 plus k1. I'm erasing the k1 out here. Okay. Now let me simplify this one. N is equals to m1g cos alpha into, let me take the LCM, m1 plus m2 minus k1 m1 plus k2 m2 plus k1 m1 plus k1 m2. Okay, if I multiply k1 by the LCM denominator, what will happen is I'll get these two terms. Now what will happen? Minus k1 m1 and plus k1 m1 cancelled. Okay, so out here This is getting cancelled, and this is getting cancelled. Okay. So anything left to take common, m2 can be taken common out here. Okay. I'm taking m2 also common out here from the numerator. M2, or m2 is taken common, then we are left with k1 plus k2, or if I write it neat and clean, is written as k1 plus k2. Okay. Or m1 m2 g cos alpha. I'm rearranging this term to be m1 m2 g cos alpha. m1 m2 g cos alpha. So the value of normal reaction force, okay, that is acting between the two bodies at every acceleration when the bodies are joined together, is equals to m1 into m2 into g into cos alpha into k1 plus k2 divided by m1 plus m2. Okay. Achha, I have made a little bit of error out here. The value of k2, this entire term was inside a bracket, no? So whenever minus is multiplied by this term, it would be minus k2. So out here it would be minus k2. So k1 minus k2, not k1 plus k2. Okay. So avoid making some silly mistakes out here. What this question is trying to say is there are two blocks, M1 and M2. Okay. The coefficient of friction between M1 and the inclined plane is K. Now the question is asking find the ratio of M2 by M1, okay, when the block or when the entire system starts sliding towards that side. So whenever there is start sliding, that means you have to take acceleration nearly equals to zero. You do have to put the direction of acceleration, do have to put the maximum value of friction force. Just at the starting of acceleration, the value of acceleration will be nearly equals to zero. Case B, okay, the entire system starts sliding in this direction. See, the difference between case 1 and case 2 is nothing but in case 1, when the entire blocks move towards that direction, okay, what will happen? The friction force would pull at along this direction, okay, and in case B, whenever the entire system is moving along this direction, what will happen? The friction force would start moving, or the friction force would act along this direction. Why? Because friction force always opposes relative motion, okay. And case number C is nothing between case A and case B. So let's draw case A. Let's draw the free body diagram out here. This is mass m1. The component of gravitational force is m1 g sine alpha, and this is tension T force. The tension T force acting out here, the tension T force acting out here. Tension always acts away from the body. Okay. And the friction force in case A would allow opposite to the direction of acceleration, where acceleration is tending to be in this direction, which has a magnitude of nearly equals to zero. The value of acceleration is k m1g cos alpha. Why? Because friction force is always equals to mu into m. And if I solve the y-axis, in y-axis n is equals to m1g cos alpha. Okay, so n is equals to m1g cos alpha. In irodov, mu is written as k. Okay, so if I take body number 2, m2, if I draw the free body diagram, m2 and t, okay, the acceleration will be nearly equals to zero. Okay, so now I'm writing down the equation. I'm taking the direction of acceleration as positive. Okay, it's really a good practice. Minus k minus k m1g cos alpha, okay, minus m1g sin alpha is equals to 0. From the second free body diagram, I'll get m2g minus t is equals to 0. If I solve this one, I'll get t and t would get cancelled. So m2g minus k m1g cos alpha minus m1g sine alpha is equals to 0. Okay, now I'm dividing this entire equation. Okay, I'm dividing the left hand term by m1g and right hand term by m1g. Why? Because I need to find the ratio of m2 by m1. See, find the ratio of m2 by m1. Okay, or m2 by m1 is nothing but m2 by m1 minus k cos alpha minus sin alpha is equals to 0, or m2 by m1 in the first case it will be k cos alpha plus sin alpha. So m2 by m1 for the first case is equals to k cos alpha plus sin alpha. Okay, now in the second case what will happen when the entire block is trying to slip in this direction? So in the second case, case B, the direction of acceleration would be reversed, is in this direction, this happens in this direction. Okay, when the direction of acceleration is reversed, what changes out here? The value of friction force starts acting on this direction. So out here the friction force will change its direction. Why? Because friction force always opposes relative motion. Okay, or tends to oppose relative motion. Okay, now if I draw the entire equation once again, what will happen? See, out here I'm just rubbing this and drawing the entire equation once again. Okay, it is nothing but m1g sin alpha minus k m1g cos alpha minus m1g sin alpha is equals to m1a. Okay, and since both of them have the same acceleration, why? Because they're connected. See the diagram. If this goes down by acceleration a, this will move up by acceleration a. So similarly, from this diagram, we get m2g minus t is equals to m2a. If you calculate the values, m2g minus k m1g cos alpha minus m1g sin alpha is equals to m1 plus m2 into a. Okay, now I divide the entire same equation by m1. Okay, left hand side by m1 and right hand side by m1. Okay, so I get the value m2 by m1 g minus k g cos alpha minus g sin alpha is equals to 1 plus m2 by m1 into a. Okay, or acceleration would be nothing but, I'm taking g common. Okay, g m2 by m1 minus k cos alpha minus sin alpha is equals to, sorry, divided by 1 plus m2 by m1. Okay, I've taken this entire term to the denominator is equals to a. Okay, now if I take minus common out here, it will be k cos alpha plus sin alpha. See out here. Okay, m2 by m1 in the question, the value is given as 0.66. K cos alpha plus sin alpha, the value is given as 0.5866. 0.5866. Okay, and m2 by m1 is 0.66. So if I redraw the equation or redraw the equation by values, I'll get g, the value of g is approximately equals to 10 into 0.66 minus 0.5866 divided by 1 plus 0.66 is the value of acceleration. Okay, and instead of taking g as 10, let's take g as 9.81. Why? Because anyway you have to use calculator for solving this irodov problem. For the acceleration, the answer is given in terms of g, so you can directly take g out here. The answer comes out to be 0.05 into g is equals to l. So the value of acceleration would be equals to 0.05 into acceleration due to gravity. Achha, so look at this question. Okay, in this question what is being said is that there is a ground. On top of this ground, a block of mass m1 is kept. On top of mass m1, another block of mass m2 is kept. Okay, and this m2 experiences a force that is varying with the time and given by the relation F is equals to at. Okay, where a is nothing but a constant. Okay, find how the acceleration of Planck W1 and W2 depend on t if the coefficient of friction between the bar and is equals to k. That means the coefficient of friction in this surface is given as k. Okay, the coefficient of friction between these two blocks is given as k, and the coefficient of friction between the ground and block m1 is given as 0. That means out here coefficient of friction is equals to 0. Why? Because this is frictionless. Okay, what the question is asking is draw the approximate plots of these dependencies. That means draw acceleration versus time graph of m1 and m2. Okay, this is my question. Okay. So these kind of problems are known as block on block problems. block on block problems. Okay. The easiest way to solve this, okay, is step one, find common acceleration. Okay, find common acceleration. Step two, find maximum acceleration. Find maximum acceleration assuming full value of friction force. Full value of friction force. Okay, and the actual acceleration is the minimum value of common acceleration and maximum acceleration. So out here common acceleration will be given as c, maximum acceleration will be given as am. Okay, actual acceleration is equals to minimum of common acceleration or maximum acceleration. Okay, so this is the process by which you have to solve the problem. But how do I apply this process out here? See, out here, draw the free body diagram. On M2, okay, force is being applied is equals to A into T. Now this M2, as it tries to move forward, this M1 will pull it back. So friction force from this surface is equals to this side, and the value of friction force is equals to how much? Kmg, Km2g, Km2g. One thing to note out here, this Km2g is the maximum value of friction force. Okay, friction forces are self-adjusting in nature. That means until and unless F80 is greater than this value, the full value of friction force won't be applied out here. Okay. Similarly, if I draw the force on F1, or friction force is equals to Km2g. Okay. Now problem is what is maximum acceleration and what is common acceleration. Common acceleration and maximum acceleration. Common acceleration is when the bodies are assumed to be fixed. Okay, that means this body is fixed to this one. I have assumed that these two bodies are locked. And the common acceleration is nothing but the acceleration assumed both the bodies are locked. Okay, maximum acceleration is nothing but, see, out here. What is pulling this block M1? This friction force. Is there any other force on this block? No. So the maximum possible acceleration of this block is nothing but AM. Okay, block M1. And why didn't we apply maximum acceleration out here? See, out here there are two forces, F is equals to AT and friction force. So out here there are two variables out here. So cannot decide what happens out here. It's easier to decide out here. So out here you have two acceleration, maximum acceleration of block M1 and common acceleration of block M1. Okay, and the real acceleration would be minimum value of whichever has a minimum value. If common acceleration has a minimum value, it will be this one. If maximum acceleration has a minimum value, it will be this one. Okay. Okay. Now for maximum acceleration, sorry, for common acceleration. Okay. Let's see this body. In this body, what happens? M2 and M1 are welded together. So this F is driving both the bodies together. So force, which is equals to A into T, A into T is equals to M1 plus M2, total mass into common acceleration. Because out here, friction force won't be applied. No, why? Because both the bodies are welded together. That means the friction forces are inside forces, or do not care about the friction forces, whatever happens inside. Okay, or common acceleration is equals to AT divided by M1 plus M2. This is the common acceleration. Now out here, let me check what is the value of maximum acceleration. Step 2. maximum acceleration. For maximum acceleration, force is equals to how much? K m2 g is equals to m1 into maximum acceleration, or maximum acceleration of block 2 is equals to K m2 g by m1 is equals to maximum acceleration of block m1. See, now this block m1, which is driven by only friction force, has two kind of acceleration, either common acceleration or maximum acceleration. Now you have to decide which has a minimum value. Okay, which has a minimum value. The minimum value is given by, see, if this has a minimum value, then block m1 will have this value. If this has a minimum value, then block m1 will have the value of this acceleration. Whereas this block will have an acceleration of another value, a m1, or maximum acceleration of block m2, a m2. So for a m2 we can write force minus k m2 g is equals to m2 into a m2, but a m2 is nothing but the maximum acceleration of block 2. A m2 is nothing but maximum acceleration of block 2. Okay, where a m2 is nothing but at minus k m2 g by m2 is equals to a m2, where a m2 is nothing but the maximum acceleration of block m2. So out here we obtain the common acceleration is at by m1 plus m2. The maximum possible acceleration of m1 is k m2g by m1, and the maximum possible acceleration of m2 is at minus k m2g divided by m2. Now see, this force is varying with time. So at time t is equals to 0, this has a very less value. Okay, so out here common acceleration will have a very less value, which is much lesser than the maximum value of acceleration. So initially they'll both move together with the common acceleration. So if I draw the graph of acceleration versus time, both will move together with common acceleration for certain time, and the value of acceleration is given by a into t divided by m1 plus m2. See, this equation can be written as y is equals to mx, where constant is nothing but a divided by m1 plus m2 is nothing but the constant or slope of this line, and t is nothing but the time, ac is nothing but the acceleration out. So till time t. Now I have a question. What is this time t till both will move together? The time t is when this common acceleration is lesser than the maximum value of acceleration. So till common acceleration is lesser than the maximum value of acceleration, or till at by m1 plus m2 is lesser than k m2 g by m1, or till t is lesser than k m2 g by m1, k into m1 plus m2 divided by a, or time till time t is equals to lesser than k m2g divided by m1 into m1 plus m2 divided by a. Okay, that means till this time, okay, till this time what will happen? Both will move with common acceleration. Now let's erase this one. Okay, after this time what will happen? After this time what will happen? After this time, out here common acceleration, okay, is much greater than maximum value of acceleration. Okay, so out here we'll take the maximum acceleration. Before this time, what is to happen? Common acceleration was lesser than maximum value of acceleration, so we take this acceleration. So whichever has a lesser value, we take those acceleration. So out here for maximum acceleration, when we are taking maximum acceleration, remember the block will move separately. That means the maximum acceleration of m1 would be very different from the maximum acceleration of m2. So from this point, both the blocks will move differently. So let's take the maximum value of acceleration of m1. See out here, this is the maximum value of acceleration of m1. Okay, what is the maximum value of acceleration of m1? K m2 g by m1. This entire thing is a constant. Okay, this entire thing is a constant. So this block m1 would move with acceleration k m2 g by m1. Okay, okay, and this block acceleration am2 would move with at minus km2g divided by m1 divided by m2, or this can be written as am2 is equals to at by m2 minus k into g. Okay, this can be written as the equation y is equals to y is equals to m m is nothing but the slope, which is equals to a by m2 minus m into x minus c. Y is equals to mx minus c. Okay, so out here the slope would be something like this, which is different from this is the acceleration of m2. Okay, the acceleration of m2 is given by this slope, and this slope is a little bit different. So let me erase this one. Okay, let me erase this one so it will be easy. So out here slope of m2 would be somewhat maximum value of slope of m2 is equals to at by m2 minus k into g. Okay, and out here what is the equation of common acceleration? Out here equation of common acceleration was at divided by m1 plus m2. Hope you understand the problems or specifics of block on block problems. Okay. Now what I'm trying to do is I'm trying to do a problem from HCB. Okay, this is a three body problem, block on block problems. So you might have a question, sir, why suddenly HCB from irodov? See, since you are learning block on block problems, so this is one of the fundamental question. So does the method that I applied before apply on this problem too? Let's check. Okay. So out here there is a question. There are three blocks, 2 kg, 3 kg, and 7 kg. This surface is frictionless or coefficient of friction 0.0. This surface has coefficient of friction 0.3, and this surface has coefficient of friction 0.4. A1, A2, and A3 are the acceleration of this block, and this block. Okay, the question is saying find A1, A2, and A3. Okay, when at 10 Newton, case 1, find A1, A2, and A3 when 10 Newton is applied out here. Okay, find A1, A2, and A3 when 10 Newton is applied out here. Find A1, A2, and A3 when 10 Newton is applied out here. So start with solving case 1. Case 1 is nothing but when 10 Newton is applied on the 2 kg block. So case 1. Good. So whenever you have block on block problems, always divide the blocks into two body problem. So out here this is 2 kg. This is being applied by 10 Newton. See. So first thing is I'm solving for this surface. So when I'm solving for this surface, this will be one body, this will be another body. Okay. So 2 kg and 3 kg, 7 kg. 3 kg, 7 kg. Let me draw it. 2 kg, 3 kg, 7 kg. Okay. Now see. What is the common acceleration? Common acceleration means I have to assume all these three blocks move together. Not all these three blocks. This first block and this second block move together. This first block and this second block move together. So common acceleration is nothing but total force divided by total mass. Total mass is nothing but 7 plus 3 plus 2, which is equals to 12. Okay. Why? Force is equals to mass into acceleration, or is equals to 5 by 6, or is equals to 0.833 meter per second square. Okay, so common acceleration is 0.833 or 5 by 6. meter per second square. Common acceleration is 5 by 6 meter per second square. Okay. Now what do I have to do? I have to find out the maximum value of acceleration. So out here 2 kg block 10. Okay. What is the maximum value of friction force in this surface? The maximum value of friction force is nothing but mu into n, where n is equals to how much? 20. Okay. So 0.2 into 20 is nothing but 4. So out here 4. And in this block 7 plus 3, 10 kg. Okay. Out here also let's combine the blocks. 10 kg, 2 kg and 10 kg. Okay. Okay. Now this 10 kg will experience a force of 4, where maximum acceleration is equals to 4 divided by 10 is equals to 0.4 meter per second square. And out here maximum acceleration is equals to force, net force. Net force is nothing but 10 minus 4, 6 divided by 2. So 6 divided by 2 is nothing but 3 meter per second square. Now one more thing. This maximum acceleration is greater than this value, which is nothing but 0.833 meter per second square, whereas this acceleration is lesser than this value. So which acceleration should I take? I'm always saying take the minimum of uh, common acceleration and maximum acceleration. See, I have to take acceleration out here. Okay, I have to compare this value and this value. Why? Because out here the friction force is the driving force. Out here there is another force to drive the body. Okay, so but out here the only force driving this 10 kg block is the friction force. So I have to compare these two values. Maximum value of acceleration is 0.4, common acceleration is 0.833. Okay, so out here will the body slip? Yes. Why? Because maximum acceleration has lesser value than common acceleration. So this surface is slipping. Okay, that means the 2 kg and the remaining 10 kg will move separately. So the value of A1, I'll get value of A1, or the acceleration of this block is nothing but 3 meter per second square. 3 meter per second square. Okay, but the acceleration of these two bodies is 0.4 meter per second square. Which values did I compare? The minimum of this value and this value. The minimum of value where friction force is the driving force, and to a common acceleration. Understood? I'm always value comparing the values where friction force is the driving force. Okay. Okay. Now see, these two blocks move together with common acceleration of 0.4. So now what happens if I solve this? I already know acceleration this block 2 kg block moves with 3 meter per second square. Now let's solve for 10 kg block. 10 kg block is divided into 3 kg, okay, and 7 kg. Okay, this 3 kg block already has a force of 4. Now what is the maximum value of friction force out here? The maximum value of friction force in this surface is equal to 0.3 into 50. Why 50? Because the normal reaction force is 5 into g, 50. Okay, so 0.3 into 50 is nothing but 15. So out here 15, out here 15. Okay, out here maximum acceleration would be 15 divided by 7 is equals to 2.1 something meter per second. Acha. Out here, since friction force is the driving force, we have to compare this value and this value. Out here, what was the common acceleration between 3 and kg block? Common acceleration was 0.4 meter per second square. Common acceleration of 3 and 7 kg was 0.4 meter per second square. Okay, so which has a lesser value, 0.4 or 2.1 meter per second square? 0.4 meter per second square. So if 0.4 meter per second square has lesser value, that means they'll both move together with common acceleration. So these surfaces will be locked. So A2 is 0.4 meter per second square, and A3 is also 0.4 meter per second square. Why? Because both the surfaces will be locked. Why? Because the common acceleration is lesser than the maximum value of acceleration. Understood? Now let's solve for case 2. Case 2 is when 2 kg, 3 kg, 7 kg. Okay, 2 kg, 3 kg, 7 kg. Case 2 is when 10 Newton is applied on 3 kg block. Okay, now whenever there are three body problems, he can either make this one body, this is the second body, or make this one body, this is the second body. Both will have the same result. Okay, it depends upon which surface you are solving for first. So suppose I'm solving for this surface first. Okay, these three body problems will be converted into two body problems, where 2 kg and out here 10 kg, out here 10 kg. Okay, what is the common acceleration assuming all these bodies move together? Common acceleration is nothing but 5 by 6. See, I already obtained in previous thing question, previous part of the problem. What is the maximum value of acceleration? See, where do you have to find out the maximum value of acceleration? You have to find out the maximum value of acceleration out here. Why? Because in this body, 10 Newton is already applying the force. Okay, this 7 plus 3, 10 kg. So 10 Newton is applied out here. When you're solving for this surface, okay, what is the force or what is the friction force out here? Maximum value of friction force is 4. Okay, and out here 4 will pull it backward. Understood? So out here, which maximum acceleration do you have to compare against this value? The maximum acceleration out here or the maximum acceleration out here? Where is friction force the driving force? Friction force is the driving force out here. Okay, so we have to compare this value of maximum acceleration and this value of common acceleration. So maximum acceleration is equals to how much? 4 divided by 2, 2 meter per second square. Okay, so between this value and this value, which is lesser? This value. So out here, this surface do not slips. Okay, this surface stays locked together. Okay, so when these two surfaces locked together, let's take for this surface. Okay, so these two surface 5 kg, 7 kg. Okay, this is being applied 10 Newton. Acha. Out here the maximum value of friction force is 15. Out here the maximum value of friction force is 15. Now tell me, where do you have to find out the, or where do you have to compare the maximum acceleration? Maximum acceleration of this body against this value, or maximum acceleration of this body against this value? Where is friction force the driving force? On the 7 kg block. So you have to compare the maximum acceleration out here, which is equals to 15 by 7, or is equals to 2.1 meter per second square. 2.1 something. Now see, between this value and this value, which has lesser value? 5.6, 5 by 6. So if common acceleration has lesser value, then that means this body will also move with common acceleration. So what will happen is this surface is also locked. Okay, that means all three bodies will move with common acceleration 5 by 6. 5 by 6 meter per second square. 5 by 6 meter per second square, and 5 by 6 meter per second square. Okay. On the third case, case 3. Now you are solving for case 3. Case 3 is when 2 kg, 3 kg, 7 kg. Okay, 2, 3, 7. The force is applied on the 7 kg block. The common acceleration will be 5 by 6 meter per second square. Okay. Now suppose I'm solving for this surface. So when I'm solving for this surface, these two bodies will be grouped together and this body will be thing. So 5, 10, 5, 10. Okay. where, sorry, 5 7 not 10, 5 and 7, 5 kg and 7 kg. Out here 10. Okay, what is the maximum value of friction force on this surface? 15. So out here 15, out here 15. Which surface, which maximum acceleration I have to compare? Maximum acceleration of this body versus this body, or maximum acceleration of this body versus this body? Where is friction force the driving force? This is friction force the driving force. So I have to compare maximum acceleration of this body versus common acceleration. So out here maximum acceleration is equals to 15 by 5 is equals to 3 meter per second square. Which has a lesser value, 3 or 5? 5 by 6. This has a lesser value, so common acceleration has a lesser value. So if common acceleration has a lesser value, that means this body, both the bodies will move with common acceleration. Okay, so out here these two bodies are locked. Now see, for this surface, okay, I have to take 2 kg block and 10 kg block. They are now both moving with common acceleration. Okay, the force on 10 kg block is 10 and the force on 2 kg block is 10. What is the maximum value of friction force in this surface? 4. Out here 4. Now where do you have to compare the maximum acceleration? Maximum acceleration out here. Why? Because the friction force is the driving force out here. Okay, so maximum uh, value of acceleration is equals to how much? 4 divided by 2 is equals to 2 meter per second square. Which has a lesser value, 2 or 5 by 6? 5 by 6 has a lesser value. So even these two bodies, okay, or even these two bodies will move with common acceleration. So out here even these two bodies are locked. Okay, find out the common acceleration, find out the maximum acceleration. Whichever has a lesser value, that will be the acceleration. Understood? And for maximum acceleration, you have to take the body in which friction force is the driving force. Okay, to compare the maximum acceleration should be compared on the body where friction force is the driving force. Understood? So this is one of the fundamental three body problems from HC. So if all these three body move together, the value of A1 would be 5 by 6 meter per second square, A2 would be 5 by 6 meter per second square, and A3 would be 5 by 6 meter per second square. So this is another example of block on block. Okay,